Alright, so I have started the class now. So quick question to you all. What are we going to learn today? Hey Saranya. We are going to talk about some interesting concepts around isolating quantities and then do a recap of our understanding of quadratic equations, and then we will look at how do you mix the concepts of linear equation, quadratic equations together to deal with some more interesting problems. Area. Okay. So we'll start with isolating quantities. Now when we talk about isolating quantities, there are some very basic but interesting concepts that you guys, I'm sure you all are aware of, but we need to be doubly aware of it. When I look at this sign, this equal to sign, it's like my pathway for moving things from one side to other side, or from this side to this side, or vice versa. And there are certain rules to be followed. Yeah. So, and those should be like, that should be always with us, like it's like ABCD, which we don't forget. It's not sticky anymore. So it's an authentic classroom for you guys. Okay. So this equal to sign, it has a very important role with respect to how we deal with different types of equations, and we should be very, very conversant with this when it comes to doing any operations. Hey Davik. So let me just check if everybody is there in the class or not, and at least I should be aware of who all are in the class. Davik joined just now, and then everybody else I have already greeted. So we have Praneeth as well in the classroom. So let's start now. So this equal to sign, this plays a very, very important role with respect to how we deal with different operations. So for all the kids who have joined just now, there are three concepts that we are going to focus on this entire week. One is isolating quantities, which is going to be a very important part of dealing with different operations. Second is a quick recap of how do we deal with quadratic equations. Some of you already know, some of you don't. So we will go through that, and then we'll practice some problems. And then we'll deal with a combined system of equations where one is a linear equation and one is quadratic equation, and how do you use that for solving different types of problems in the real world. Alright? Vishwa, is that okay?
Yes, sir.
So we are starting with isolating quantities. Now, these are the things that you need to keep in mind. When you are moving a plus to other side becomes minus. When you are moving minus to other side becomes plus. You can envision it like this, or you can envision it like this. Both ways is fine. From one side you are moving to other side, you are changing the sign from plus to minus, minus to plus. No matter from which side to which side. Okay? And if you don't have a sign, if I just say 3 equal to 8, this is hypothetically correct, but let's say you have next. If I am trying to move, I have 3 plus x. If I don't have anything in front of it, simple assumption is there is a plus. There is a hidden plus. When you don't have a sign, you have a plus sign. Everybody with me so far, right? I know these are very basic, easy concepts, but we will just make sure that we don't worry about these concepts when we are dealing with any problems. Maybe Vishal. And so this is about plus and minus. And second thing is divide and multiply. Same thing. When you are dividing something, when you have to move a division, some number with a division sign to other side becomes a multiplication, or vice versa. So there should not be any confusion. Or one thing you can remember is in case of fraction, you have this butterfly method. So if you are talking about 3 by 5 x equal to 8 by 9, and you have to find out x, Let's not worry about that. Let's worry about only moving this thing. So here you have nothing, it's like a multiplication thing. It becomes a division. Or if you are getting confused, look at this way. 3 will come down, 5 will go up. And no sign will become a multiplication sign. So when you're dealing with plus or minus, no sign means a plus sign. If you're dealing with no sign, you're talking about a multiplication sign. Yeah? So this is, all of you who have watched old movies of kings and all, you would have seen those, those soldiers, they keep this thing, right? I mean, two javelins, they will keep crossing each other. We will use that as a butterfly method. So now you guys will think that, okay, what a childish thing we are talking about. These are not childish, they are the basic building block that we will use for dealing with all the problems relating to isolating quantities. Now, when we say isolating quantities, what are we actually talking about? If I say that we are going to learn about isolating quantities, what is that comes to your mind in the first place? I'll come to you, Praneeth. Let me bug everybody else. I know you have an answer for me. When we're talking about isolating quantities, what do we mean by that actually? Anybody? Neil, Sarah, Ria, Ritika, anybody. Just give me a simplest possible or a lame definition of how would a child understand what do we mean by isolating quantities. Yes, Ritika, go ahead.
Wait, so like does it mean like where you put like the variable on one side and like the equation across the other? So
I mean, that is essentially what we do, but in the simplest form. Isolating quantities. We are isolating the quantities. Or here quantities is a term that we'll use interchangeably for variable or constants both. Yep. What was your definition?
I was going to say taking a part of an equation or inequality and setting it on one side.
That's fine. Tell it again.
Taking a value from a equation or an inequality and setting it to one side of the equal to sign and putting everything else on.
Right. So basically, see, ultimately, beat. You're okay, right? It's not very hot. That's why I turned it off, because it was making noise. So obviously, we'll deal with a lot of problems relating to this. But as a starting point, first of all, can everybody see the whole board, or part of the board is hidden? No. Okay. So let's look at this. If I say, I don't say. When we talk about dealing with equations, be it linear equation, quadratic equation, polynomials, whatnot, ultimately, what are we talking about? We are talking about something which has some knowns and some unknowns. These are the knowns. They will never change. These are unknowns, which we call as variables. So all these equations are meant for finding out the value of unknowns. Yeah? Simple enough for us to be on the same page. So ultimately, be it solving any kind of equation, ultimate goal is to find out what is not known. Yeah? Samriddhi, Jana, you guys are with me so far? Okay. So, and now if you look at this, so here in this equation, this is the simplest or the most substandard question for you guys, right? I mean, you guys have dealt with much more complicated questions than this one. But still, as a starting point, if you look at this equation, obviously this also gives the same definition, that this is an equation where you have an equal to sign. You have some knowns, 5 and 13, knowns or constants, whatever you call it, and some unknown, which you are trying to figure out. And how would you figure it out? Ultimately, your goal is to do what? You are trying to say what? S is equal to what? And how would you get that? When you isolate X. When you make sure that you have only X, you are not trying to find out this. You are trying to find out this. And that you can achieve only by isolating it from the whole world. If I have my money, Praneeth's money, Jana's money, Samriddhi's money, Dev's money, Biswa's money put together is $500. If somebody says how much money your teacher has, I have a cumulative money, I have a group money, I don't have my individual money. For you guys to find out how much money I have out of 500, you have to isolate me. You have to say, okay, fine, let's take Pranita out, let's take Vishwa out, let's take Jana out, let's take Samriddhi out, right? And that is how you will know what you are wanting to know. So, net, you will see that when you are talking about isolating quantities, you are talking about whatever you want to find out, whichever variable value you have to find out, you have to isolate that guy. You have to keep that guy on the other side, meaning everything else has to move to other side of equal to sign. That is how it will become x equal to something. And to get to that, as I was saying, how do you move? So that's what we were saying. Plus becomes minus, minus becomes plus, butterfly method, division becomes multiplication, whatnot. So here, simplest example, if I move this guy to other side, then we'll get what we are wanting to get. So that means 13 and this plus 5. If I have to move this guy, if I have nothing, if I have a plus, it goes to other side, becomes minus. Is this what you are going to get in SAT exam? No. This was just a jump start kit, okay, for us to make sure that conceptually we have nothing bothering us. Let's say if you have to find out x into 3 by 9 plus 5 equal to 6 by 8, and what will you do? You would want to keep x on one side, everything else moves. So here it goes up in the opposite direction as BODMAS. In BODMAS you will say divide, multiply first, or PAMDAS, whatever you guys remember. You will say, okay, first I will do bracket, then I will do multiplication, division, then I will do addition, subtraction. It is just a reverse. It is just, when you are trying to isolate this guy, you will say, okay, fine, whatever is with x together, that I will deal with separately. Let's not relate that with BODMAS, I might be wrong with my statement. But operation wise, we will say, okay, fine. Whatever is with x, we will deal with that later. Everything else moves. So this goes to that side, becomes minus 6 by 8 minus 5, then you have x into this. So now you are in the situation where you have x into this equal to something, and then you will apply the butterfly method. Yeah. So this was just a prelude of what we are going to learn. Now let's look at some legitimate problems, because these problems, if I keep on teaching you guys will know what is my level of understanding with respect to isolating quantities, and that's something I don't want to expose. Yeah. All right. So let's pick up some interesting problems. But before I get going, Saranya, Samriddhi, Riya, Ritika, Vishal, Davik, everybody with me so far, right? Everybody. All the names that I called out versus the names I missed. Yeah. Now time for a roller coaster. Let's look at some problems that I have put for you guys to look at. And again, regardless of whether I am teaching the toddlers on math foundation or I am teaching the college students, we will never ever move away from this unless you guys say that this is obsolete, is not helping. Okay, till that time we'll keep leveraging this as our technique. Now I'm reading the question for you guys. The question says u equal to half kx squared. I'm writing this equation, okay? U equals half kx squared. And there's a story behind. It says the elastic energy of an object U is determined by its absolute compression x, determined by the absolute compression x, and the spring constant of the object k. So basically this is something that is determined by this and this. That's what it means, okay? Whether you call it absolute compression x and spring constant k, or you just know it as two unknowns, okay? As shown in the formula, which of the following correctly shows the object's absolute compression in terms of its elastic energy and spring constant? I'm reading the second part of the question, okay? It says, I'm just repeating it one more time. This is the equation given, u equal to half kx squared. Elastic energy u is determined by its absolute compression x and spring constant k of the object as shown in this formula. Which of the following correctly shows the object's absolute compression? This is absolute compression and this is the spring constant. You are given 4 options and you have to find out which one determines the value of absolute compression. X is the absolute compression, okay? X equals Ku by 2. Second option is X equals 2U by K. Third option is X equals 2U, 2 square root 2U by K. And fourth option is X equals 2U by K x squared. 2U by K whole square. Lonanya. Yes, Dave. Which option you are leaning towards?
Difference between
B
B and C.
and C. Yeah, so here x is square root of 2u divided by k. Here it is 2u by k whole square.
Oh,
Yes, Vishal.
I think the answer is the second one.
B.
yeah, I also think it's B.
Okay. So when you guys say I think, I'm assuming there is a back behind calculation, the back end that has happened, right? You also think B? Okay. Now I'm not trying to pull your legs. I'm just trying to confirm that when you guys say I think, it has to be a derived answer saying this is my answer. Okay? I want that confidence level to go to the next level. Enanya. Ejana, yeah, tell me.
I think it's B.
You also think it's B? So, I mean, this is certainly not an English class, so I am not here for correcting English, and I can guarantee that you guys have better English than mine. But when it comes to the statement that I want to hear from you guys, which gives me or which boosts my confidence, you will say my answer is B. Okay? I want to kind of pump it up. So Ananya, you got a little late today, but what we are going to cover today is we are primarily talking about isolating quantity concepts, and then we'll talk about quadratic equations, how to solve quadratic equations, and then we'll go on to solving system of quadratic and linear equations. Yeah. So we are just dealing with solving or isolating quantities concepts. Yeah. Jenna, you are saying something, or you want to pull your hands down?
Oh, my bad.
No, it's okay. I was just curious. Anybody else who still has some doubt or thinking about it? Saranya, what's your answer, beta? I'm sorry, beta?
I didn't solve it yet.
No, so I was saying Saranya. So we have matching names, Saranya and Ananya. So I want to give you some time, Ananya, because you just joined. So this is the question. You have this equation given where U is the energy, this is the compression constant or something, and this is the spring constant. This is okay. Let me read that for you one last time. The elastic energy U is of an object is determined by its absolute compression x and the spring constant k based on this formula. Which of the below correctly shows the object's absolute compression, which is x, in terms of its elastic energy and the spring constant? So basically, you are given this formula where U is the energy, this is the constant, and this is the compression, and we have to find out compression in terms of K and U. Yes, Ananya.
I got C.
You got C. How about Saranya, Vishwa, Vishal, Sara, Neil, Samriddhi? So, little louder, better.
I got B.
You also got B. Okay,
Doing it, sure.
you're doing it. Okay, so we have a lot more to cover. So I'll give you guys one more minute. This is the easier of the lot. That's why I'm trying to rush through it. There's no big deal about it. We just have to deal with all, or we have to just recollect the different techniques that we need for maneuvering variables across the equal to sign. Ritika, how about you, beta? What's the answer?
I think it's B, but I'm not sure. I need to like double check.
Double check, beta. As I said, I don't want to hear, I think, I want to hear my answer is B. Right or wrong doesn't matter. Yeah? Because my answer is what will go in the exam. I'll give you guys 1 minute. In the meantime, I'll just get my water bottle. I forgot. Okay. Is everybody ready with the answer? So here, this is the thing, okay? When you're looking at this, you can solve it in 30 seconds or maximum 1 minute. It will not take much time. Maximum time and energy of yours will go for reading it, just to make sure that you're not making a wrong judgment, okay? Now let's look at it. You're trying to find out the value of x, meaning you want to come to a situation where you have x equal to something. That means you will start moving everything one by one. So first let's move the numbers 1 by 2. It is on the first floor, it goes to the second floor. It becomes 2 by 1. 2 goes up, 1 comes down into u equal to kx square. You just moved the numbers. Now when you want to get x, so that means you have to move k also. So k also moves like this. When you talk about multiplication division using the butterfly method, from the second floor it will come down 2 by 1 into u by k equal to x square. So you got 2 into u by k equal to x square. 2 by u, 2u by k. 2u by k equal to x square. So x will be equal to square root of whatever you have. So that is how it will be b.
Oh, I get it.
Yeah. Is everybody clear about what I did? Nothing complicated about it. It's like straightforward, step by step. That's why I was insisting on saying that, okay, you tell me my answer is this, because this is my answer. I can contest this, I can argue about this answer for next 2 hours if somebody wants to prove me wrong. So I want you guys to have that level of conviction when you give me an answer. Yeah? Is everybody clear? Saranya, Nanya, Samriddhi, Neil, Sarah, Vivan?
Yep.
Everybody? Okay, let's move on. So this was again not a difficult one of the lot, but the problem is, see, there's no problem that is difficult or easy. It is always up to us how we look at them and then how do we solve them. So is there a problem difficult? Maybe, may not be. It's always up to us. Let's pick up another problem. I would not say difficult or easy. Let's see, what do we have? Now I have another one that should not take more than 2 minutes for everybody, okay? If it's taking more time, that means we are probably missing something. We have an equation w equals 6 plus 3xy by 75. It says the equation gives the quantity w. This is the quantity. I will write a quantity so that I don't keep on forgetting, which I always do. Quantity w in terms of the quantities x and y. Oh, so this is quantity and this is also, these are two different quantities. Which of the following equation correctly expresses y in terms of w and x? So w equal to 6 plus 3xy by 75. It says which of the following equation correctly expresses y. So you have to find out y. Y equal to y. And now if you ask me why we have to find out y, I don't know why. Okay, that was a bad joke. Let's carry on. The options you have is y equals 25w by x minus 6. Second option is y equals 25 plus W, 25W plus 150 by X. Option 3 is 25W, Y equals 25W minus 150 divided by X. Yay, Y equals 25W minus 2 by X. These are 4 options you guys have. So everybody got the question, right? W is a quantity represented in form of, in terms of X and Y. You have to find out what is the value of Y and you have to pick one of the choices. Again, it's all about how you are making your numbers move. Yes, Jenna.
Do you think you could move the camera a little bit to the right?
Yeah?
Oh, okay. There you go. Thanks.
Mm-hmm. Okay. Who's ready with the answer? Yes, V1.
Sir, I got C.
You got C. How about Ritika?
I got C as well.
Okay. B. Okay. All right. And like I keep on reducing my age, right? I always say, okay, I'll behave like a 5-year-old. So I know it sounds funny, but always whenever you guys are solving it, always solve like the simplest possible way. Don't mix and match too many things. You also think? See? Okay, Davik has been very quiet today. Davik, I know mosquitoes were bothering you too much. I got 2 mosquito killers in the classroom. Yes, Vishal.
I got C.
You also got C. About Davik, Sara, Neil, Saranya, Viswa.
I'm thinking, sir.
Okay. Dev, how about you?
I need to look more.
Okay. What's happening with Davik? And everybody who has got their answers, I would suggest use that wait time for revising it, because there is no harm in being more than 100% confident. So again, let me take out 0 from my age. Like I say, I'm not 50 yet. Next year, few more months to go. But yeah, let me turn a 5-year-old child and then try solving it. So ultimately, I'm just going to play with numbers. Right? You call it hide and seek, you call it something else, doesn't matter. We have W equal to something and we have to find out Y. If I have to find out Y, meaning everything else has to move to this side. Everything. And we have to move it step by step. First thing I'll do is move this number 6. Because that's very easy, right? It's like somebody who doesn't have friend. It's easy to separate them out. Correct? This guy is having friends, right? It becomes difficult to move somebody, right? So this guy is lying isolated. It's easy to move that guy. Then that gives you 3xy by 75. Okay? Now, other thing is, see, as I say, we always, you see, 3 times 25 is 75. So let's simplify it. I don't like big calculations. So 3 into xy by 75 I can write as 25 into 3. Now, I'm talking about w minus 6 equal to xy by 25. Okay? So we anyways remove this 3 also. Now what we have is x into y by 5. If I want to only keep y, I have to move both x and y. And when it goes, it becomes a multiple of these things. So w minus 6, whatever we have here, 25 goes up and x comes down. See whichever matches with this guy. So you see that you have x at the bottom, all of them. So that part is fine. Now here you have to look at 25 into 6 and 25 into W, whichever matches with that. So you have a minus sign here. Whichever has plus, you can knock it off. You don't need that. And again, X is a common denominator. So this one also you can knock off. Not needed. So between this one and this one, 25W minus 150. See, 25 when you multiply it back, 25 into 6 will be 150, 25 into W will be 150. Sorry, 25W. So 25W minus 150. 25 minus 2, 25W minus 2 doesn't hold any chance here. So we are only talking about this one. So again, if you look at the whole calculation, even if I would have not done the simplification, that would have been fine. Okay? I just did that because now while doing calculation, if I am dealing with smaller numbers, it makes my life little easier. Okay? So what did I do? Moved X first, then move these two things, simplify this to 25 and X by 25. So if I move X by 25 to the other side, only Y remains here. The only thing that you have to be careful about is when you are moving this thing. So you have multiplication division thing here. When it moves, it cannot multiply with one of these. It has to multiply with whatever you have on this side, on the right hand, on the left hand side. So that's why I put a bracket here. So bracket's job is to make it more explicit, less ambiguous. Actually, if I don't put a bracket and then I say okay, 20, this is what I will end up doing by mistake. Y equal to this. Then okay, I multiplied this. But you don't have to multiply with one of the terms here. You have to multiply with everything that you have on this side. So that's why putting a bracket makes your life a little easier. Yeah. Is everybody with me so far?
Yes, sir.
Yes, Jenna.
I have a question.
Yes, please.
So on the second step, why do we make the number 25?
So I have 3 by 75. Okay. I have very basic problem in life. When I'm dealing with bigger numbers, I find it difficult. My chance of making mistake is more. That's why I said okay, 3 and here I have 75. This 75 I can write as 25 into 3. So then I did tic-tac-toe. And this became xy by 25. Does it make sense, Peter?
Yeah, yes.
So basically,
It's
see,
made it more simplified.
right. So ultimately, I mean, as I always say, right, I assume myself to be a simple person, and I want to be that way. When I am a simple person, meaning I deal with simple things in a better way. So when I have a bigger calculation, let's say somebody says 14 divided by 254, it looks little overwhelming to me. Table of 14, yes, I remember. But if I break it down like this, 127 into 2, this makes me feel little better. 7 by 127 compared to 14 by 254. So I always keep looking for opportunities to simplify the calculation that I'm dealing with. So that way my chances of making mistake gets minimized to an extent. Yeah? Okay. Is everybody with me so far? Ananya, Saranya, Ritika. I keep bragging about my personality, right? I mean, unfortunately, there's nothing to brag about. I'm just a simple person. Yeah? And that's what I want to reflect in my calculations also. Yeah? Alright. So let's look at something more interesting, or in somebody else's term, more complicated. If there's a complicated problem, I cannot solve it. So I'll first try to find out ways to simplify it. Okay? And that's what I'll keep on teaching you guys. Okay, one last question and then we'll go on to quadratic equations. Now this question says Q equals A minus I by L. The formula gives the quick assets ratio Q ratio Q in terms of company's current assets A, inventories I, and current liabilities L. Asset, inventory, liability. This is the relationship given. Okay. This is the quick asset in terms of assets, inventories, quick asset ratio. Okay. So asset ratio is asset inventory divided by liability. This is a formula given. Which of the following equation correctly gives the inventories in terms of quick asset ratio and current assets and the current liabilities. So basically it's saying you have Q in terms of A, I and L. Find out I in terms of Q, A and L. Meaning keep I on one side, everything else goes to the other side of the wall. And I will not give you options. I want you guys to derive it. It should not take more than a minute. If it's taking more than a minute, that means we are making it complicated.
I equals
I equals
negative QL plus A.
okay, we'll see. Alright. Everybody else. I got one answer. I'm not convinced. I don't want anybody to be convinced because we have not done it ourselves. And everybody has only 2 minutes because I want to start the journey with quadratic equations, look at all the concepts, things that need to be aware of, do at least a problem today, and then we'll do more problems tomorrow, and then try marrying the concepts of quadratic equations with linear equations. Everybody got the question, right? Riya, Vishal, Vishwa, Vivan, everybody? Okay. And I'm randomly calling out names. I have no hidden agenda for anybody. Only one agenda. Let's learn. Yes, Vishal.
Are we trying to find the Q?
I. Q is already given to us. We are trying to find out I.
Then what's that second equation next to it?
This is one of the answers I got from Praneeth. He told me I can be represented in the form of Q and Q in terms of Q, L and A like this. I'm not convinced. I don't want anybody to be convinced. You have to find your own answer.
I don't get it, sir.
I'm Sailaka.
I don't get it.
Okay. So let me repeat the question. Yeah, Vishal, tell me what your answer is.
I got the exact
Same answer. Okay. So Vishwa and for everybody who is trying to figure out what we are trying to do, we have this equation given. Q is something, A is something. It says some assets ratio, quantity asset ratio or something. Forget about that. We are given the relationship between Q, A, I and L. We have been asked to find out what is the value of I, meaning I, like we have Q in terms of A, I and L, we have to find out I in terms of Q, A and L. Meaning we have to get to a point where we have to say I equals something. And like Vishal and Praneeth gave the answer, I want you guys to find out your own answer. Unless you are extremely convinced that this is the right answer. I'm not convinced. I don't want to be convinced in the beginning unless I do it myself. That's a personality flaw I have. Yes, David.
I got I equals to A minus QL.
I equals A minus QL. Okay. How about Ritika? You got same as the first one? Okay.
The second one's the same thing, it's just different.
Yeah. So, David, your answer and this one is same. I also did not pay attention to it, but it's the same thing. I equal to minus QL plus A, or I equal to A minus QL. You have just flipped the position, that's it.
I couldn't read that, so.
Oh, okay. But yeah, good that you did it yourself. Okay. So Neil, Sarah, Saranya, you guys are very quiet today. What about you guys? Yes, Jana.
The answer is I equal A minus QL.
Yeah. Okay. Same as David, or same as what Praneeth and Vishal also gave. I'm sorry, David.
Sorry, like my cousin came in.
Okay. Yes, Ananya.
I got I equals to A minus AL.
A little louder, better.
I got I equals to A minus AL.
2A minus AL. This is not Q, it's L, right? Q. Oh, you said QA. Okay, my bad. Yeah. Okay. My ears need a little bit of maintenance, it seems. Okay. So let me. So everybody got the same answer. Let me also do it one last time. And when I have a situation like this thing I can take care of in one go. A minus I. Ultimately, what I want to do is I want to have only I on one side, but I cannot do it in one go. So first thing I'll do is let's move this L to other side. So from the bottom it will go to the top. It will become Q into L. So A minus I equal to L into Q or Q into L, whatever you call it, or QL, LQ, whatever you want to name it. So let's say QL. Everybody has given QL, so I'll keep it QL. I want only I equal to something. Here I have a minus I. If I move this guy to this side, it will become a plus I. But I don't need a friend of I. I wants to be lonely. So I will only move I to this side and move QL to this side, so that I remains as lonely as it wants to be, and then everything else on the other side. So I, when it comes to this side, becomes plus I or I, whatever you call it, equals A, and this QL has nothing meaning, it has a plus sign here. Goes to that side, becomes minus QL. That's it. So these are basic maneuvering techniques, I would say. You're just practicing how do you maneuver your variables from one side to the other side, so that you can isolate what you want to isolate, and you'll say, okay, fine, this is what my answers are, or this is what my answer is. Now, enough of playing with math. Let's play more. Because playing with math never gets tiring, okay? As long as you're actually playing, as long as you are learning something and then you keep on applying and treat that like a game, it's actually fun. So let's move on to the next thing, which is quadratic equations. And many of you have heard how to solve quadratic equations, what are different methods of solving quadratic equations multiple times from me. So I will do it more like a crash course, or I'll try skimming through it real quick, but then memories are not long lived, right? I mean, they come and disappear. So we might touch upon those things as needed, depending on everybody's comfort, and we'll make sure that any and every concept relating to quadratic equation, we touch upon those. Even if you're not able to solve any problem today, that should be okay, but we should be 100% clear about those concepts. And then when we come to solving quadratic equations and system of linear equations together, we should be able to apply it like butter. Okay. So I hope if nobody has any, what you call, the dairy allergy, right? I was giving an example of butter. So anyways, let's keep aside that bad joke. So these are some of the formulas which we call as algebraic identities. There are three basic formulas that I would want everybody in the class to be super duper conversant with. A plus b whole square equal to what? A minus b whole square equal to what? A square minus b square equal to what? And again, as we say, a plus b whole square is nothing but a plus b into a plus b. When you say a minus b whole square, that is nothing but a minus b into a minus b. And again, how do you use the distributive property for breaking it down and getting this formula? Why it is important? Because tomorrow somebody says solve x square plus 2x plus 1 equal to 0. Solve it for x. As soon as you see this equation, you will say, oh, this is x square plus 2 into 1 into x plus 1 square is 1. It is x plus 1 whole square. Oh, I'm talking about x plus 1 whole square. So that means x plus 1 whole square equal to 0. That means x plus 1 equal to 0 into x plus 1 equal to 0. How this will be 0? This is either this is 0 or this is 0. Both are the same thing. So that means x plus 1 equal to 0. From this you find the answer saying x equal to minus 1. So this becomes more like a silver bullet, saying that okay, if I have a quadratic equation to solve, and if I can convert that into one of these form, a plus b whole square or a minus b whole square, or a square minus b square, meaning I am able to convert that to something into something, meaning I am able to factorize the whole quadratic equation. Applying this formula, my life becomes easy. If I say x square plus 12x plus 32, is this a square? No. But this 12x I can break into x square plus 8x plus 4x plus 32 equal to 0, and then I can say okay, I will take these two together and these two together. Here what is common? X is common, it becomes x plus 8. Here what is common? 4 is common. 4 times x plus 4 times 8 is 32. Oh, I got x times x plus 8 plus 4 times x plus 8. So I can write this as x plus 4 into x plus 8. What did I get? Something into something equal to 0. Meaning either this is 0 or this is 0. When this is 0, that means x plus 4 is 0. I got x equal to minus 4. When this is 0, x plus 8 is 0. That means x equal to, it goes to the other side because minus 8. So we got two answers for this, or two solutions for x. Was this a perfect square like this? No, it was not. We found another method. And that method relates to this concept of, this is a standard form of the quadratic equation. Yeah. Everybody convinced? Everybody knows about it, right? This is a standard form for quadratic equations. Vivan, have you heard about this, beta?
Yes, sir.
Okay. So this is a standard form of quadratic equation. Now it says that when you don't have everything in the perfect square form where you can factorize it straight away, what you need to do is look at this and this, a and c, meaning the coefficient of x squared and the constant. Multiply them. Whatever you got, create the factors of it. Let's say this got, let's say 4 into 5, 5 into 9. No, I'm just making it up. This is not right. This cannot be the case. Let's say 4 into 9, 9 into 4, 6 into 6, 12 into 3, 18 into 2, 36 into 1. So basically my A and C, here I assume that this is 36. So what are the ways I can factorize it? I can put this as 4 into 9, 9 into 4, 6 into 6, 12 into 3, 18 into 2 or 36 into 1. Nothing is tricky. Come inside and sit as if you are not here.
Yes.
You are not here. I don't want to hear yes also. Sit down in that corner without you being here. So these are the factors you can get from 36, and then look at which two of these can give you a B. So if you look at this example, what did we have? A was 1 here, this was 32, so we got 32. A into C got me 1 into 32 is equal to 32. Then we looked at what are the factors of it. I can factorize this as 16 into 2, 4 into 8, 2 into 16, 1 into 32. Yeah. Now, out of all these combinations, which combination I can take and add them together or subtract them to get this value? See, 12, 16 and 2. If you do 16 plus 2, it becomes 18, which is not the case. 16 minus 2 gives you 14, that is not also possible. Same thing here, not possible. 1 plus 32 gives you 33, or 32 minus 1 gives you 31, not the case. But if you look at this guy, 4 plus 8 is 12. Oh, I can break this into 4 plus 4x plus 8x. That's what we did. And we've got a perfect factor here. So this is your second method. When your quadratic equation doesn't give you a straightforward square form, you look at second option, where you will envision your quadratic equation in the standard form. Look at what is your A, that is coefficient of x squared. Look at what is your B, that is the coefficient of x, and look at what is your C. And then you multiply A and C together. Whatever value you get, see what are the factors you can break it into, and which of the factor together gives you a value of B by adding it or subtracting it. Okay?
Yes, sir.
You're not here. I'm not joking. During the class, I'm not joking at all. Keep quiet. Okay. All right. So everybody here. Clear? Everybody clear? Vivan, Dev, Davik, Jana, Ritika, Saranya, Sara, Neil, everybody, right? Okay. So, just give me a minute.
Sunil,
Yes, sir.
I was late.
It's okay. Come on. You have to wait here for 7 minutes, okay? Your son is starting for the class. Right now, there is some serious discussion going on with senior high schoolers, okay? You can sit down here. All right. After 1 year, after 1 hour. So, your class will start in 5 minutes, okay? So, you have to just listen to me. All right. So, this is the second method. Either you look at these this algebraic identities, or this method, or there is a third method which we call as the silver bullet if you rely on your memory a lot, and that is called quadratic formula. Okay? So, how does it work? Quadratic formula, again, the standard form of a quadratic equation is x squared plus bx plus c equals 0. The quadratic formula says that you don't have to go anywhere. You don't have to go here, you don't have to go here. You can straight away, if your memory is better than your teacher's memory, you can find out the answer for x. You can solve it for x from this equation, which is minus b plus minus b square minus 4ac by 2a. I was just getting confused. Do I start with 2a here? No, then I recollected. Okay. So here, any quadratic equation when you solve, you can get up to 2 answers or 2 solutions from it. And one solution is when you go for the plus option. Other solution is when you go for the minus option. So Lakshmi, you are few minutes early for the class, but 5 minutes. Just bear with me for 5 more minutes. So here, again, just to do a recap, any quadratic equation, if you can convert that to the standard form, any of these, you get a factor immediately, solve it for that. If that doesn't work, you look at the second option, where you look at factorizing these two, multiply these two, and then see how you can factorize and get a b by adding the factors together. A third option is your magic wand. If you remember this formula, you can apply this formula for solving for x or y, whatever variable you are dealing with. Okay. Come inside the class without making sound. Your class has not started yet. You have 4 more minutes to go. Okay? So, you are not in the class yet. Don't waste everybody else's time. Alright. So, there are 3 methods, and so far we have only touched upon the theory part of it. I'm pretty sure most of you were aware of these things, but it gets more fun when we actually practice or solve the problems applying these concepts. So, that concept application, I will keep it for tomorrow. That is where on this formula we'll talk about something called discriminant, which will tell you whether a quadratic equation will have 1 solution, 2 solution or no solution. Okay, so we'll talk about the discriminant tomorrow, and then we'll apply these concepts. And I'm not going to talk about the linear equations, but we'll do the application of linear equations in the class tomorrow along with the quadratic equations, just to give you guys a glimpse. If I'm talking about a quadratic equation, when you try plotting it on a graph, it will plot a parabola. And if I'm talking about a linear equation, that's a straight line. If you have to solve for x with 2 equations, one is a linear equation and one is a quadratic equation, maximum solution you can get is 2, where your line intersects the parabola. Meaning there will be 2 values of x which will satisfy the condition for the parabola also. Or there could be a situation where the line will not even touch this. There is no solution. So we'll deal with all those different possibilities in the class tomorrow. Break our head with that and see if whatever we have learned we are able to apply that successfully and solve the problems or not. Any questions before I let all the senior kids go? Otherwise you is already ready to go. Now? Go, daddy is waiting for you outside. Okay. Alright. So have fun. See you guys tomorrow, same time, and that is when all the theory that we have learned today, we'll be able to apply them. Alright? Bye bye. Bye bye. Bye bye. Bye bye.